Can you all hear us? Great, thank you. Yeah, so I'm Benjamin Parkin from the Financial Times, and I'm joined by Manish Bhatia, the Executive Vice President of Global Operations at Micron Technology. Micron is building a multi-billion-dollar assembly and test chip-making facility right here in India, just across the state border in Gujarat, and we could start seeing India's first domestically manufactured chips coming out within the next year. Manish runs Micron's end-to-end operations around the world, and as such is very well placed to talk about why semiconductors are crucial to AI, the world we live in today, and India's role in it all. So thank you very much for being here. Thanks, Manish.
Thank you, Benjamin.
To start, tell us about the industry. For those who aren't fully familiar with the extraordinary significance of semiconductors to our world, explain briefly how they work and why they're so important.
Sure. So, well,
I think is your mic on?
I don't know, actually. Do I need to turn it on? I think it should be on. Can you hear me? I'm not sure. Maybe I have to go old school.
Right.
On green. Yeah.
It's not working.
I don't know. Can you hear me? Okay, then I'll just go ahead. Oh, there we go.
Yeah.
All right, so global semiconductor industry, I think everyone probably understands broadly how semiconductors power all electronics and increasingly devices that are not even considered to be electronics, increasingly semiconductor content in automobiles, in consumer products, in sensors and other applications across the many different industry verticals are really becoming ubiquitous. Semiconductor industry has grown to be last year slightly higher than $500 billion, so $550 billion industry. It's really comprised of maybe three core segments and types of products that we build as an industry, and I'll get to Micron in a minute. We build, the largest segment is processing, CPUs, application processors for smartphones. Of course, increasingly everyone wants to use GPUs for parallel processing for artificial intelligence applications, field programmable devices. There's many different categories of processing. This is obviously the ones that we're maybe most of you are most familiar with. Intel, NVIDIA, AMD, Qualcomm, all fall into this category. Memory is the second largest segment. That's where Micron is a leader. Memory really broadly in two different categories: dynamic random access memory, DRAM, which is high performance memory, very close to the processors, but it's a volatile memory which only stores the data when there's power. And then NAND flash, which is solid state memory, high performance memory, higher performance than disk, not as high performance as DRAM, but importantly for all the phones and videos you store on your phone, the data stays even when there's no power applied. So the memory segment is slightly larger than 20% of the industry and growing, which I'll talk about. And Micron is a leader in memory in both DRAM solutions and NAND flash solutions. And then the third big category are broadly the more trailing edge semiconductors that are used primarily for analog applications. Analog as opposed to digital, meaning sensors or power management or voltage regulators or any of those types of segments which are needed to interact with the physical world. So all of these segments actually have been growing broadly over the last several years, and as I mentioned, getting to record levels of more than $500 billion in revenue as an industry, in the last 18 months. And the path and trajectory and outlook, given the applications that are ahead of us in artificial intelligence, which will really fuel demand for all of these segments of semiconductors, expected to double that $500 billion to $1 trillion by the year 2030. So amazing to think that semiconductors were invented about 6 decades ago, and in those 6 decades till today, we were able to get from zero to $500 billion. And in just the next 5 or 6 years, we'll have the next $500 billion of industry market opportunity across all these different segments.
So can you explain to us what goes into making semiconductors and why they are so difficult to make? I mean, the scale, the rate at which they shrink and get smaller and smaller is literally mind-boggling. Tell us a bit about that.
It is. Really, manufacturing semiconductors at the leading edge is more complex than any other manufacturing process on the planet. There are thousands of process steps, each with their own nanoscale processes that need to be defect-free, fully defect-free, so that at the end of the processing for the wafer or for the assembled package, that you're able to have high-yielding product that has high reliability. And the observation of the great Gordon Moore, who was one of the founders of Intel maybe 50 or so years ago, his observation in the very early days of the industry is that new process technologies to be able to bring active devices like transistors or capacitors closer together, build them smaller and have them come closer together, would be doubling every 18 to 24 months. And it's that incredible rate of progress that it's unlike any other industry. Imagine that within 18 or 24 months, we are retooling factories to be able to produce the next generation that will be smaller, more cost-effective, lower power, and higher performance all at the same time. Now, in order to do that, what we have to do, though, even though the devices that we're producing, the chips that we're producing are smaller, the facilities we produce them in actually have to get bigger because the number of processing steps continues to grow. The number of processing steps of a leading-edge technology 10 years ago was maybe 1/4 the number of process steps of a leading-edge technology that we have today. So it's actually growing in terms of manufacturing intensity, in terms of cycle time, process steps, capital intensity, at a rate that's faster than ever before because it's that much more complex to be able to pattern these devices on the silicon wafer or to be able to assemble these very, very complicated high-performance packages and to be able to test these high-performance devices. All of these are becoming more and more complicated. And again, every 18 to 24 months, we're rolling out and completely retooling to be able to support the next generation of products. So there's no industry that I can imagine that's anywhere like it.
Yeah, it's extraordinary. So, and what does the rise of generative AI and AI mean for this process, and how is it changing the semiconductor industry and Micron's operations?
So, we've been, as an industry, we've been driven by cloud computing, really a few different vectors. If I go back to the late 90s, Benjamin, you and I were talking about, late 90s, 2000 was the PC and internet era, and that drove scale for processing and memory to new levels. Then there was the mobile era about 10 years later, around 2010, with the advent of the smartphone, the iPhone, and then many others coming, and that drove the next step up in terms of semiconductor content. And then cloud computing and the big data kind of era maybe about 5 years ago, and then now transitioning from the big data artificial intelligence era to now the generative AI era. And what's unique about both of these, whether it's the big data era or the generative AI applications that we're now seeing as so transformative that are ahead of us, is both of them at their core are about data. At their core, the value is in the data. The larger the data set that you can train on, the larger the data set that you can mine for insights, the more powerful the results, the more valuable the results, the more accurate the results. And that's true whether you're talking about a deep learning network that's trying to solve for some kind of algorithmic question, or using an algorithm to be able to solve for some question, or whether you're trying to generate content for software coding or text or video, whatever the generated content is. The larger the data set, the better the result, and therefore memory becomes more valuable, whether that's high-performance memory like DRAM and all new applications. You probably heard a little bit about high bandwidth memory, which is a new and exciting capability that links up with GPUs to high performance memory that together can have bandwidths that are multiple orders of magnitude higher than standard products. And this kind of bandwidth is what's needed for the generative AI to be able to deliver on its promise, and is really the backbone of what we're going to see, computing systems shifting to in the future. Or as more and more content gets generated by these new engines like OpenAI and others, that content needs to be stored somewhere so that it can continue to be trained. It's a continuous training loop where the more content that's generated, the more that you have to train on, the better the future content results will be. So memory actually much, much more valuable in the AI era than it has been in the past and continuing to grow. So if memory during the PC era was around 10% of the global industry, mobile and cloud era about 20%, we see it growing to be 30% of the industry, approaching 30% of the industry moving forward. So by 2030, if the global semiconductor industry is $1 trillion business, we would expect memory and storage together to approach 1/3 of that, and that's just an amazing opportunity ahead for memory.
Yeah. So as that happens, tell us about the supply chain and how it's evolving. What does it look like today? And particularly India, what role does India currently play in the supply chain, and what role does it want to play?
Yeah, well, I think I think during the pandemic, everyone realized, due to shortages in almost every electronic area, the value of having supply of semiconductors, right? And I think AI has just put a exclamation point on that by seeing that how transformative the AI applications can be for economic security, national security, and uplifting the standard of living for everyone. So all countries around the world, you can see all regions are trying to have semiconductors as part of their strategy. India has been very, very strong. I think most of the people here in the audience would know in terms of design and development, because the design of semiconductors, the simulation that goes into designing chips is very similar to the kind of the infrastructure that's required to be doing software development or cloud service development. So all of these kind of share common infrastructure and capability. But hardware development of process technology and manufacturing is an area that requires a very different capability for India. It requires significant investment in infrastructure to be able to have, and the ecosystem to be able to build these high purity clean rooms, to be able to have the power and the water that's required to be able to have leading edge semiconductor manufacturing capability here. And of course, training a workforce that can operate in a way where it's not about being creative in terms of developing new software code. It's about being able to monitor manufacturing, understand sources of variability, understand how to optimize productivity, improve yields, improve quality. It's a very different skill set, especially for something as complex as semiconductor manufacturing, which is completely order of magnitude different than the types of manufacturing India has thrived in before because of the capital intensity and the requirements for the complexity of the devices that we're building. So I think it's great that India has now launched their semiconductor policy, and Micron was the first company to announce a large-scale project. We're very excited about our project in Sanand, Gujarat, just outside of Ahmedabad. In fact, I was just there this week, taking a look at our progress in building this large-scale facility, and we expect early next year to be in production there, and we'll be assembling and testing advanced DRAM products as well as advanced NAND flash products, not just for the Indian market, but for global export as well. So these products will have to meet the standards of all of our global customers, whether they're in smartphones, whether they're in cloud computing, whether they're in automotive. India will have to meet those standards, and so we're very focused on delivering that at scale.
And so what would you say is India's competitive advantage then as it tries to build up this the hardware manufacturing sector? Is it the existing design capabilities, or?
I think that certainly that helps, and having that capability and background helps. I think certainly India has a few things going for it. It's when you think about the previous speaker was talking about India's goal of going from 5th largest economy in the world to, it's almost an inevitability it'll be the 3rd largest economy here in the next few years. That population growth of all the large economies in the world, developed economies, there are really no other countries that have the population growth and the youth of the population and the strong institutions, whether those are legal institutions, educational institutions, and other government institutions. All of those things coming together are going to help fuel India on this journey. So those are all huge, huge competitive advantages. And I think the talent pool available is maybe unmatched in the world when you think about the quality of the higher primary education, higher education, English speaking. So I think companies have been tapping into India's talent pipeline for a long time, and now we're just trying to move that to be able to tap into it in manufacturing.
So the government has put a lot of importance on building this domestic industry. What are the main challenges, I guess? What are the obstacles that need to be overcome in order for it to succeed?
Yeah, I think first and foremost, it's around infrastructure.
Yeah.
Semiconductor processing, I mentioned, is so complex. Even, give you an example, even a fraction of a second of power droop, not power outage, right? I mean, I grew up in the States, but I've been coming to India for almost all of my life, maybe for 50 years, and seeing the improvements that have been made in infrastructure for residential communities has been amazing. But still, it's a totally different thing to say, it's not just power continuity. We can't have power droop for even a fraction of a second without having millions of dollars of product that's at risk or damaged, right? So just think about the kind of resiliency that's required in the power infrastructure, similarly for water, similarly for how we manage our, the wastewater that comes from the processing. All of these things require logistics for the airports and the roads. All of these things are much more challenging than, say, residential requirements that have grown up in the past, more challenging than what's required for, say, data centers or others, right? So this is something that is definitely a major focus area. The other one is in the certainty of policy. I think, I mentioned many of the advantages that India has, and stability of the government, democratic nation, that's an advantage over many of the other, developing countries that are vying for some of these big manufacturing investments. But being able to take this semiconductor policy and create certainty around it, not just for the Indian market, but for creating an export-capable market, that certainty of policy is what's going to be needed to attract more and more companies like Micron in our industry. Not just our the manufacturers, but those in the value chain, whether it's our customers, whether it's our suppliers of specialty materials, specialty chemicals, services, engineering support, design services, all of these coming together. They're going to want to have a predictability of policy, not just for the next 5 years, but for the next 25 years or beyond. And the reason that's so important is because semiconductors are the most capital-intensive industry on the planet. Our suppliers are also similarly very, very capital-intensive. So unlike, say, building a factory to assemble bicycles, where you have a relatively small capital investment and a large labor investment, the return on that small capital investment can be seen very, very quickly. When you have huge billions of dollar capital investment, the returns on those are seen over 15, 20-year periods to be able to be realized. So you need to have predictability of policy. We're not going to be opening and closing factories. Once we make a decision to plant roots somewhere and capitalize the factory, continue to grow it, you're not going anywhere. The semiconductor industry will come up in these small clusters, or I shouldn't say small clusters, large clusters in relatively few areas around the country. And this is the stability of predictability of policy is what's going to be needed for everyone in our industry to be able to invest with confidence. That's what's been able to take place in Taiwan, in Korea, in Japan, many of the countries where there are thriving semiconductor ecosystems. And I think India, I mentioned, it took 60 years to get to $500 billion in revenue in our industry. It's going to take 5 to get to the next $500 billion. I think India has a tremendous opportunity ahead of it to be able to create all of the factors that can make semiconductor manufacturing successful over the next 5, 10, 15, 20 years. But it's going to take directed policy and alignment between all the stakeholders, whether that's central government, state governments, educational institutions, all of them together will need to be focused and wanting to have that capability.
So we're almost out of time. Final question. You talked about the 10, 20-year time horizon. I mean, what do you think the industry will look like 20, 25 years from now? I mean, I'm asking you to speculate a bit, but based on the rate of growth that you've talked about, the transformations, how different or not will it be in the future?
Yeah. Well, I think some things change, other things stay the same. I think the things that will change, we all probably can see science fiction movies about what the future is going to look like, how ubiquitous computing with memory, analog sensors in the world. What that's going to do, I think many other speakers are more qualified to talk about, but there's no question, I think we can all agree, that semiconductors are vital to be able to power all of that, all of those capabilities that can be imagined. So those things are going to change. The things that will stay the same, I believe, are the things that matter in semiconductors are technology and technology leadership and the cadence of technology. I don't believe that will change. I don't believe that the requirements of scale or the key enabler of scale as a value driver in our industry, that's not going to change. Factories are only going to get more and more expensive. Processes are only going to get longer and longer. Equipment is only going to get more and more precise, more and more expensive. So those things are going to be happening, which means, I think fewer and fewer companies are going to be able to be investing at that scale and that kind of technology level. And so, I would expect to see the growth to be in the hands of those who can harness those who've demonstrated those capabilities to date and will be able to harness them for the future.
Interesting. Well, thank you very much, Manish, for your time, and thanks to all of you for being here and for listening. It's been really fascinating.
Thanks, Benjamin.
All right.
Appreciate it.
Okay.
Yep.
For more content on tech and leadership, subscribe to NASSCOM YouTube channel and press the bell icon to never miss an update.